Hello everyone, welcome back to 3D CAD tutorials. I first of all I thankful to everyone who have subscribed to my channel, and if you are not yet subscribed to my channel, please subscribe to my channel. Today we will discuss about the initial days of a mechanical engineer. Usually when we are entered to the mechanical engineering field, we don't have any kind of idea how many types of domains are there, and manufacturing sector as well as a design sector as well as a production sector. There are so many types of sectors you can see there. If you go with manufacturing, there you have someone will work in shop floor in front of a conventional machine, CNC machine, and few will work as a programmer for few machineries, and few will work in assembly section, few will work in QC department, and few of them are very much interested to go for the white collar job called as the design engineer, or we can call as a product designer. So here once we go there, there are a lot of things are there, as there is a saying called the mechanical engineering is the backbone of all engineers. So without a mechanical engineer, the world can't we can't imagine the world. So here when we come to here, there is a machine design, jigs and fixture design, mold design, press tool design, then casting design, die casting design, then pipeline piping design, and so many sheet metal design is there. You get there are so many types of designs are there. Few of them is like hybrid. Suppose if you are started your career as a mechanical designer, if you are having a very good knowledge about practical things like what is turning, milling, grinding, jig boring, jig grinding, wire cut, EDM, and what are all the constraints in the each and every level, that is good. Because if you start design without knowing the limitations, then you can't analyze the things, is it possible to manufacture or not. So then every time it is like revising the drawings and reviewing by your seniors, and it is like you may get frustrated or you may get demotivated by that one. So for that, what I will suggest, you should know the limitations of the manufacturing. Suppose I will take an example of a sheet metal. If you design a sheet metal, you should know what is the up to what thickness we are calling as a sheet metal. First thing. So here I will just put the questions in front of you. I will explain all these things in the upcoming videos. If you are having any doubts regarding manufacturing design, you can put it in my comment box. So here once the sheet metal came into picture, so there is a what is punching, uh, and then what is piloting, and what is lancing, what is the embossing, so what is blanking, and what is punch, what is die, and what is the clearance for that, and what is the progressive press tool, and what is a compound tool, and single stage tool is how we can do. So these are all the things, and what are all the materials used for the dies and punches, which is the best method. So how much HRC should we should maintain for the punch and die. So what is the hardness, how it plays a very important role, the hardness. When sheet metal means the uh, hot rolled sheet will come, and cold rolled sheet also, sheet metal will come. So which is the best one for laser cutting, and which is the best one for punching, bending, or in when if you take sheet metal only, the rolling operation how you will do. If it's in a 90-degree bend, if it's in a cylindrical bend, then how you have to split into different sections, and you have to achieve that one. And what is the limitations while you are welding? If the sheet thickness is not uh, at the higher end, if it's a very lesser thickness, it will shrink. So you should aware of all these things: what is TIG welding, what is MIG welding, what is arc welding, and what are all the possibilities you can achieve the uh, design in a required manner. So these are all the things you have to think in a positive way. I am not demotivating anyone here. So if you are having this kind of knowledge, then you can design a better product. That is my concern. My concern is always to motivate the people who can come forward and work as an leaders. So my thinking in such a way, if I ask questions, you will at least you will search here or there, because you may think the name is 3D CAD tutorials, but he's giving a speech about manufacturing. Is it relevant or irrelevant? If you see, there are thousands of cross together models are in front of you. I will also add few more, no issue, in the upcoming days, and I will move to the 3D modeling of a solid surface, sheet metal, and die casting tools, press tools, mold, how we can design. I want to give a complete picture about the mechanical field. Uh, I'm never telling in such a way I know everything. I will explain, but what I know I will share with you guys. If you are having any doubts, please share to me. So when we come to that is regarding the sheet metal. So when you are doing sheet metal, so what is if you use paint, then if you use the powder coating, suppose if you using blackening, suppose if you use in which cases we have to use that one, and how much mm, uh, years, how many years, or what is the durability of that one. So these are all the things we have to consider. So sometimes if you come to steel, that is different. If you come to stainless steel, that is different. Mild steel is different. And if you come to aluminum, that is different. Copper is different. So like that, there are a lot of things. What I will suggest, you should have a minimum knowledge. I am not telling you should expertise in all the things, you should know calculation, everything, but at least you should know the limitations. Suppose if there is a solid part, if there is a solid part, is it possible to convert to the sheet metal part? If anyone asked, you should thoroughly understand the things, and you have to conclude that one, yes, it is possible or not. If it is yes, how you can achieve. If it's not, why it is not possible. These are all the things you should have in your mind. Suppose if you are having an L angle, suppose if you are on a L angle, the L angle is not available in the market. Your requirement is standard available maybe 50 by 50 mm. Your requirement is 65 by 50 somewhere. So it's possible to manufacture by using any sheet metal part. And what is the cost of the part? If you purchase directly and machine, suppose if you purchase the next 70 by 70 or next level, if you remove the metal, what is the cost? And if you take the sheet metal, so the manufacturing ideas, if you are having, it will helps a lot as per my knowledge. Suppose if you know about all these things while manufacturing a sheet metal part itself, you will think what is the wastage of if you to produce this part, what is the wastage will happen in the next level. How we can, you can just align the your pattern in such a way the material should not wasted. Suppose in punching, what is the space between component to component? If it's a laser cutting, what is the gap we have to give? And in laser cutting, what is the minimum hole we can produce? So these are all the things. If you check what is the diameter, what is sorry, what is the minimum diameter can be punched in your sheet metal part, and what is the minimum flange height is required. So like this you can just produce the things in a very good manner. So I will just, if suppose if you go to mechanical solid component design, suppose you are having a one turned part. So if you just giving in a cam shape at a flange, you require one flange to just mount two holes or three holes to take that material. If you are having, if you given that one, what is the amount of material to be removed? Suppose if you take an example, you have designed an odd size uh, tube like 70 dia dia 69 dia 69 id, and od is dia 80, like that. So suppose you, what is the functionality of that part, and is it required? If it's the standard available material in market maybe at 80 or 100, if you use the alternative sizes, what is the problem you will face? And how to utilize the standard components in the market to reduce the product cost or your assembly cost. So suppose if you assume, if you are a manufacturer a bearing by yourself, it is a the cost is, you can't imagine. Suppose what you are getting for 40 rupees, that may cost you for around 4000 rupees. If you produce all balls and the bearings in internal ring and external ring, and if you want to assemble, what is the setup you require, what is the time you require? So to reduce the time, to reduce the cost, to increase the production rate, it is better to use the standard materials. And you should know what is the tolerance we should give for the bearings, and what is the tolerance for the holes. If you are you suppose if you are having three plates are clamping together, so top you have to give counter bore, in the center you have to, in center plate you have to give the clearance, and the bottom you have to give the threading, then it will clamp like this. It's like an we can't conclude this much is the field. So you can having a lot of questions in your mind, you can ask me in the comment box. I will ask one by one, I will try to answer. So like this, what is the limitation in jigs and fixtures? What is the clamping mechanisms we are using? Suppose if it is a machining part, which is the area we should clamp? Suppose if it is a if you are drilling a job, the job will rotate in a z axis. So you have to clamp the job in a uh, if you suppose if you are placing in a component on a drilling machine bed, so you have to hold that one, it should not rotate in the, because from top the pressure is applying, so it will not go down because of the bed, but it can rotate. So you have to hold in such a way the axial moment should be arrested. So suppose if the job is very big, suppose you just assume 1 meter by 1 meter by 1 meter aluminum block or SS block or casted block is there. So for to drill that one, no fixture is required, because the self weight itself enough to resist the machine tool cutting force. Okay. So you should know that one. Then after machining, you should know how to measure QC. Suppose if you are a design engineer, you design something, somewhere is manufactured and it's sent to your company, and you are the only person, or you are the in charge of the project. So you should know how to use the measuring instruments. It may be a may start from vernier caliper, screw gauge, and bore gauges, and so you even from sometimes we will go to the air end like cmm also we have to use, and um, projector we have to use. So like that, there are a lot of things we should know. Sometimes you have to check the hardness, sometimes you have to check the no, thread pitch. So thread pitch gauge will be there. Feeler gauge will come to check the gap between the component to component while you are assembling. Feeler gauge we are calling. So then radius gauge is there. So no go go gauge and no go gauge will be there for holes. So like this lot of things you should understand. Suppose if you come to mold, how draft is, we should apply the draft, and how it will be helpful. Positive, what is positive draft, what is negative draft, and what is side core, and what is the if you design a component in a very complex manner, then what is how the cost will increase, and how to maintain the equal wall thickness by providing the holes, or just depression projections, so like that. These are all the things we should consider when we are designing a plastic part, and what is the plastic material we are going to use there, and what is the requirement, is that material will sustain in that environment. So all these things, what is thermoset, what is thermoplastic, even though you know theoretically very well, you should know practically about the molding, what is how their farming is done. So thermoforming, how they are doing, what is injection mold, what is rotary molding, so what is rotational molding. Like this, you should know something about the material as well as the process, and as well as the uh, quality. Suppose shrinkage, where to give the gate, and if it's an your consumer product, if gate or runner mark is coming over the external surface of your product, then very awkwardly it will come. The rework of the component or mechanical parts is always high level, higher end. So if you are doing R&D, it's better to order 2 to 3 sets of material, because if one fails, you second one we can rework and you can do. Suppose when it's coming to casting, the same thing, the almost it is similar to mold, but when it's coming to die casting, it is having some of the investment casting and pressure die casting, gravity die casting, then collapsible core, a non-collapsible core. Like this, you will have that one. So the limitation should we should have, if you come to press tool, as I explained earlier, you should know the sheet metal things. So if it's come to assembly, what is you should know while designing itself, you should know the fits and tolerances, because if you give the if you not consider the fits and tolerances, it's always difficult to assemble in assembly line. They will suffer like anything, and it is a bad name for the mechanical designer. So my honest suggestion is that one. So you should have knowledge on at least minimum shop floor for at least 3 to 4 months. Otherwise, you should work for a company in your part time to earn the knowledge how the things are going on, and how better you can improve yourself. So these are all the things you should consider. So as usual, I will continue my 3D CAD tutorials, 3D modeling as well as assembly. So what I required you from your end is I need some response from your end. Yes, one of the person has sent one model and he requested me to just model the ribs over that chocolate mold. I have done. I feel very happy to share knowledge, and if it's a challenging job, I am always happy to uh, work with you guys. So I think it is not a boring session. I'm happy uh, to continue with you guys. So if you're not yet subscribed, please subscribe to my channel. Thanks for watching.